Hi, my name is Luca Chierotti. I'm an electrical engineer, and this is my senior design project known as PACRR, or also Piloted Autonomous Crisis Reconnaissance Robot. In this project, I had three other partners. Um, two of them are computer engineers, and one of them is electrical and computer. So imagine a decrepit building has just collapsed. There's a potential gas leak inside, and you don't want to send in first responders to risk their lives, and neither do you want to send in search dogs for the same reason. So who are you going to call, and what are you going to do? Well, you're going to call our piloted autonomous crisis reconnaissance robot. So our project, also known as PACCAR, was inspired by the New York Fire Department's usage of Spot, which is a four-legged robot, as you can see on the right-hand side there, in a similar use case as I just described in the previous slide. We also had a desire to learn more about quadrupeds or four-legged robots in general. Four-legged robots or quadrupeds are better for going over rough terrain as opposed to tracked robots, which makes them perfect for search and rescue operations. And then furthermore, we also had a discussion with firefighters from both the Santa Clara and Milpitas fire departments. And this discussion influenced the requirements for our design. So the first requirement that they wanted from a potential robot would be for it to be cost effective and simple. If you have a $70,000 Boston Dynamics robot that breaks down in the field, you don't want to have to continuously buy a new one or replace it with expensive parts. So that's a key thing here. And then in addition to this, they wanted this robot to be autonomous. So that means having it be able to autonomously walk without human intervention, as well as detect obstacles in front of it. And then firefighters also noted that they wanted this to be tethered. So as opposed to having it just walk in blind and maybe fail without being able to get it out, they wanted a tether so they could pull it out in case of electronic failure or maybe a mechanical failure. And then in addition, since this is going into buildings with potential gas leaks, they wanted the ability for gas sensors to be mounted onto the robot. And then also a live feed component such that the robot could show to first responders in real time if somebody's inside and needs assistance. And then in general, they also noted how this is a proof of concept. In the future, they would want a pack of these robots, hence the name PACCAR, that could simultaneously map a building and figure out the extent of the damage in faster time. So the objectives for this project were built off of these requirements in our discussion with the firefighters. And essentially, we took an open source quadruped design from Monash University. You can see there on the right-hand side, which is an Australian university. And we made significant modifications both in software and in hardware to their design. So one of the main things is we added perception sensors. So LiDAR, which is light detection and ranging. And this forms essentially like sonar, a plane of two-dimensional depth data around the robot. And that allows us to detect obstacles. And we also added the RGB or depth camera onto the robot. You can see there in the bottom corner on the front, which allows us to have a live feed component. And then we also wanted to add software such that it could autonomously walk and map environments. And since the firefighters wanted a tethered design, we took out the existing battery power and supplied power via the tether. And that reduced weight allowed us to add both the perception sensors as well as the gas sensors on board. So you can see here the proposed framework for our project. You can see here on the left-hand side how the robot interacts with its three sensors. So we have an inertial measurement unit, which measures acceleration in three directions that then you can integrate to get position. You have that LiDAR, which gives you depth data around the robot, and as well as that camera there. And this feeds into an algorithm called simultaneous localization and mapping, which allows the robot both to know where it is in space and create a map at the same time. And you can see an example of that map in the gray box there, which is a map of SCDI 4004. And this all information from the depth data and the map all feeds into algorithms that allow PACCAR to autonomously move and avoid objects at the same time, as well as giving a live readout for first responders. So you can see here an example of PACCAR walking in real time. You can see the black lidar on top of the robot, and then we can see here the robot having mapped in the bottom corner here SCDI 4004 and what a map would look like to first responders. On the next slide here, you can see PACCAR walking while at the same time mapping its environment and avoiding obstacles. And you can see there on the right-hand slide that SLAM, simultaneous localization and mapping algorithm in action. So the red axis is the front of the robot, and this shows the correct direction as well as the correct obstacles and map of its environment. Thank you.